One of the important concepts in statistics is that of deviation. We define deviation of an entry X in a population dataset as the difference between the entry and the mean mu. This is the lowercase Greek letter mu, and it does mean the average of the dataset. And the deviation of X will be represented as X minus the mean. So X is going to represent our data value, and obviously mean is the mean of the data set. So let's look at a table and a data set. This data set is actually going to represent the daily average temperatures for 10 days in New Hampshire in February. We're going to just assume that this is a population because we're not looking at any other temperature values outside of this particular data set. So each one of these will be our individual X's. And if we find the mean of that data set, i.e. mu, that's going to be 41.5. And then I'm going to take that 41.5 and I'm going to subtract it from each one of the data values. For example, here I have 41 minus 41.5, which is equal to a negative 0.5. And I will do that for all 10 entries. And then I will take each one of these entries that results from the subtraction, and I will add them together. That's going to be what's known as the sigma x minus mu, or the sum of the deviations. And if I've done this correctly, it should be equal to 0. Now remember that this letter right here, this is the Greek letter sigma. It's an uppercase letter, and that's going to represent summation or sum of. And then we're using this as the average or mean of a population data set. Okay. Now that we've done this, what we want to do is we want to talk about standardizing this so that we know roughly how all the values compare to the mean pretty much all at the same time. And that's going to define variation. We want to know exactly how this thing varies from the mean for every single data value. And from that, we can derive something called the standard deviation, which is what will allow us to do a number of our statistical analysis. So while we've been talking about population, we also have to bring into account a sample. And let's go ahead and discuss the deviation of an entry X in a sample. And the deviation of an entry X in a sample data set is the difference between the entry and the mean, which in this case is going to be indicated as X bar of the data set. So therefore, the deviation of X is equal to X minus X bar. One way of looking at this is the deviation of a value from the mean is simply that value minus the mean, regardless of the notation that we use. All right, so let's go ahead and discuss variance and standard deviation. So we'll define the population variance using the lowercase Greek letter sigma. That's what this is. And we'll say that that is sigma squared of a population data set of n entries, where n is the number of data values. And that is given as sigma squared is equal to the summation of the quantity x minus mu, i.e. the variation, or I should say the deviation of x from the mean, and then we're going to square that. And so we're going to add all those together after we've squared them, and then we will divide by the number of data values. We're also going to take the square root of this value to establish something called the population standard deviation. So the population standard deviation, which is going to be sigma, or the square root of sigma squared, of a population data set of n entries is simply the square root of the formula that we just introduced. So sigma will be equal to the square root of the quantity, the summation of x minus mu quantity squared, divided by n. Now, this is going to make much more sense when I do an example, so that's what we're going to do next. So now what we want to do is go ahead and start to build out our table. That's going to be the easiest way to do this as far as doing it by hand. After I complete this for both population and sample, I will show you how to do it in Excel. So the next column that I want to create in my table is going to be this x minus mu quantity squared. In other words, what I'm going to do is take this value here, which is my x minus mu, and I'm going to square it. Now you'll notice that this gives or yields a positive value, and every single one of these will be positive values. So let's go ahead and find negative 3.5 quantity squared, and that's equal to 12.25. Now let's go ahead and fill in the rest of the values, and we don't necessarily have to keep writing the quantity squared notation. We can just write the squared values. Now that I've calculated all these, I want to go ahead and add all of these values together. That's going to represent the value that we had talked about in the formula. And this will add up to 88.5. Now that's our variance. Now remember, we want to take that value and we want to put that into our variance formula over here. So we can simply say that the variance is equal to 88.5. We're going to divide by n, which we know to be the fact that I have 10 values. Therefore, the variance is equal to 8.85. Now I want to find the standard deviation. Now remember, standard deviation is represented by sigma, which is simply the square root of sigma squared. We know what sigma squared is. It's 8.85, so I will find the square root of the variance to get the standard deviation. And many times, the values that we're going to end up with are going to be irrational. They will not terminate. For example, I'm going to write this one down and carry it out 6 or 7 decimal places. It's going to be 2.9748949. Well, generally speaking, we're going to round to between 1 and 3 decimal places as indicated in the assignment. In this particular case, let's round it to 2 decimal places. So let me write that down. We will round to 2 decimal places. That means that the standard deviation for this data set is 2.97. And that's going to be a deviation of degrees. We can go ahead and put the symbol, or we don't have to put the symbol, but just remember that we are dealing with degrees, so the standard deviation, it should make sense, would be expressed in degrees. Now let's talk about this in terms of variance and standard deviation for a sample, because the formulas do differ a little bit. And so now let's introduce the sample variance and sample standard deviation of a sample data set of n entries. And those are listed below. The first one is the sample variance. And you'll notice that instead of using the lowercase Greek letter sigma, we'll use little s or lowercase s, and instead of using mu, we use x bar. And so we have this for this whole expression, s squared is our sample variance. This is our mean, and instead of an uppercase n, we're using a lowercase n, and we are subtracting 1. This is for a sample. Then when we want to find the standard deviation of a sample, we simply take the square root of the variance, not unlike what we did previously. So we can go ahead and calculate these by hand, but let's go ahead and show you how to do these using Excel. Remember, as I said, standard deviation is going to be a uniform deviation from the mean for all of our data set, and we're going to use that to perform statistical analyses as we progress through the rest of the course. So as I said, we're going to explore using Excel for this. So let me go ahead and make this just a little bit larger so you can see the data set. This is the exact same data set that we used in the example when I did everything by hand. Now, we're going to both treat this as a sample and as a population. So for the first part of the example, let's consider it to be a population. We're going to find the mean the same way no matter what. So once we have our list of data values, we can go up to this section right here where it says auto sum, and I can left click and you'll see where I can either go ahead and add the column, or the next one is the average. That's the same thing as the mean, so I will left click that. You'll notice that it populates with a formula, and it also highlights all of the values that we want to be as part of our average. So in this case, we'll just go ahead and hit the enter key, and we see that our average is 41.5. Now, the next thing that we want to do is go ahead, and let me go ahead and write this as mean in the right hand cell so that we don't get confused. So the next thing I want to do is find the variance for the population. In order to do that, you need to go up to formulas and you need to have your statistical analysis pack installed, which is not that hard to do. So we'll go ahead and left click on more functions and then go to statistical. And we're highlighting statistical. And now what we want to do is scroll down until we see the word variance. And down here we see a number of different possibilities for variance. I'm going to highlight this one and you'll see it's var.p. That's the variance based on an entire population. That's what we want to use. We'll left click that and you'll notice that it gives me this function argument screen. And it's already established this A1 through A11. And if we look at that, that means that I'm looking at all of the cells in this column. But remember, I don't want to use the mean as part of the variance, so I'm just going to highlight the ones I want to be part of that. And then I will just left click OK, and that gives me the variance. Now I want to find the population standard deviation, and I can do one of two things. I can merely take the square root of 8.85, or I can go back to my statistical sub menu and then I can look for standard deviation. Now when we look for standard deviation, we see that we have STDEV, here's dot P. That's the standard deviation based on a population. Left click that. Once again, you'll notice that it's trying to use every single value in the column, but I only want to use the first 10. So I highlight that. I'm going to left click and hold and then drag down the highlight. Left click OK, and now I have my population standard deviation. So I'm going to write P-VAR for population variance, and then I'm going to write P-standard deviation for population standard deviation. Now I'm going to show you how to find a sample variance and standard deviation. And remember, they should be different because the formulas are different. So I'm going to go ahead and use this cell to calculate the the sample variance. So once again, I go back to go back to formulas, left click more functions, highlight statistical, and then I'm going to scroll down until I see var.s. This is a sample. Left click that, and once again it's trying to populate according to its logic. This is saying it should be cell A12 and B12, which would be this one where the cross is and this one where the cross is. But that's not what I want. I want to use these 10 values. So you're going to hold your cursor in this first cell, left click, and then drag to incorporate all 10 cells. You'll notice up here it says A1 colon A10. Left click OK, and now we have the sample variance. And you will notice that it is a different value than what we had for our population variance, which should lead us to believe that we should have a different sample standard deviation. And so we're going to do that right now also. So we'll highlight here. I'm going to go back up to my formulas tab, go to more functions and then statistical. and scroll down until I find standard deviation. This allows me to find the standard deviation for a sample. I left click that, and I'm going to go ahead and left click in cell A1 and hold and drag and highlight all of those, left click OK, and now I have the sample standard deviation. And we'll notice that it is different from the population standard deviation. So that's how we find variance and standard deviation, both using formulas and using Excel.